discuss about the concept of boundary value problems in a real-time scenario. So there are various scenarios in our real life where we are using boundary value problems. So one of the important area or domain where this boundary value problems are more used is where she is going to tell.
And here will be a case study on heat transfer analysis. In our industry base, heat will be prevented by insulator, which the heat will not be allowed to get out.
So like as she is telling, in industry we have very big boilers, where the huge amount of heat is getting generated. Am I right? Getting generated. So here, if you see this picture, here there is an insulator or maybe a kind of material which avoids the heat getting transmitted outside. So in our real-time situations also, scenarios, so there are various areas where we are supposed to think about this heat insulators. So not to avoid, maybe in home also, maybe at home, due to sunlight, due to summer, huge temperature generations are there. So, but what you say, I want a cool temperature inside the room. So so the temperature should be prevented. So the temperature should be prevented. Because in summer time, the degree will be 40 degrees Celsius or more than that maybe in our place also. So what you will do? So you will try some insulator. I want some insulating paints nowadays, cooling paints. Many things are there. So those insulators we want so that the heat is not transmitted that much to that level. So that comes we try to bring about the idea of this one boundary value problems in such areas where we try to define a mathematical model and we are trying to understand the heat transfer. What we are doing here as a mathematical structure or mathematical methodology, we try to understand how much heat is getting transferred. Okay, we are going to exactly picturize what is the amount of heat is getting transferred. So how can we insulate it? In order to insulate, we should know what is the amount of heat is getting transferred to the maybe a metal, whatever. Suppose there is a metal similar to that. Maybe on one side of it there is a huge heat is getting generated. So through that metal, maybe the heat may be passing. It may be passing through that metal because heat can transfer through metals. So if there is a plan to insulate, or if they want to know what amount of heat is getting transferred, we have to do something. Scenario, what we do is we define some mathematical models. Am I right? We try to define some mathematical models and we try to understand the heat distribution to particular time. Maybe in the first 10 seconds, how much of heat is getting transferred. Maybe in the next 10 minutes, what is the amount of heat is getting transferred. So, periodic heat transfer. We are trying to understand the periodic heat transfer. Accordingly, we can create some methodologies in order to maybe kind of insulation process or the particular material, what material can withstand the heat. Maybe in understanding that. Am I right? In these areas, we can use the concept of boundary value problems, because in boundary value problems we have very important things. One is we will know, first of all, we will define the boundary. What is the boundary conditions? We will have two things in very important. One is we will have the boundary conditions. We will understand all the boundary conditions of the particular situation, and the second one is we have some initial conditions also. With this, the experiment starts. With this, the concept starts. So we will apply the mathematical equations, and because we have various list of partial differential equations in mathematics for each and every type of equation. For example, for wave equation we have a separate partial equation. For heat transfer we have a specific partial equation. There also we have two-dimensional equations are there, or even if you want more than that, according to the situation. If you are working with two-dimensional area or three-dimensional area, accordingly we have mathematical equations. We are going to use that, and we will create an we can create mathematical model there. Then we will apply similarly as I said to you. What methodology we have? Standard methodology is Fourier series. So Fourier series is the standard methodology in order to solve the problem what we generated. So likewise in various areas, not only in industry, maybe at home, wherever there is a rate of change. I am talking about here, we are talking about heat transfer. Maybe it can be in another scenario also. So You can see in a pipeline, fluid is transferring. Through pipes, we can transfer fluid from one place to other. If we want to know the flow rate, what is the kind of flow rate there, that is fluid motion. So this is heat motion, maybe wave motion also. In wave motion, how the wave is moving, the displacement of a wave with respect to particular time. If you want to understand that, again, that is also a kind of transfer. So rate of change is happening. Am I right? So rate of change can be in fluid motion or heat motion or a wave motion. Am I right? So similarly, you can even say like this: heat is moving in a kind of wave. Am I right? Heat motion is also a kind of wave motion. So in all these areas, we can apply our boundary value problem concept. Okay. Thank you.